Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. On this occasion, I would like to deliver my presentation under the title Synthesis and Characterization of the Lubricity Enhancer from Palm Oil. Let me introduce myself. My name is Sofia Maspuri Walidatu Salihah. This is the introduction of this research. We know that environmental degradation due to air pollution are crucial issues that must be addressed. Creating a newer technologies by improving fuel efficiency and reduce pollution in the automotive sector is the problem solver of this case. Diesel engines are widely used for transportation. However, the effect of the emission of diesel engine are raised environmental degradation such as greenhouse effect and also acid rain. The effect of using fossil fuel is the high amount of sulfur pollution in the air, which causes air pollution and leads to releasing dangerous oxides and cause acid rain. The alternative way to reduce the sulfur content in the fuel is through desulfurization process. But this process will reduce the lubricity properties. So the most effective way in solving the lubricant problem is addition of anti-wear agent to diesel fuel. Vegetable oil can produce fatty acid methyl ester from trans-esterification with alcohol using base catalyst. The recent study was presented by recently provides lubricity improver additive derivative from linoleic oils with 1.2 ethanol using potassium carbonate as a base catalyst. And this research is study about the synthesis and analysis of the product from trans-esterification of palm oil with ethylene glycol using base catalyst potassium carbonate. This is the methods of this research consists of synthesis of fatty acid methyl ester and also synthesis of hydroxyethyl ester. The composition of palm oil was determined by BIS-MAS analysis, so the palm oil have to be changed to its fatty acid methyl ester, and the product from synthesis of hydroxyethyl ester was monitored by TLC analysis, and its chemical compound was determined by using BIS-MAS analysis. This is the procedure for synthesis of fatty acid methyl ester. Palm oil was heated up to 60 degrees Celsius and add some methanolic solution which made from methanol and potassium hydroxide as a base catalyst. The reaction time was set for 2 hours and the mixture was cooled to room temperature and add to separating funnel. The organic layer was evaporated and washed with aqua dish, dried with sodium sulfate to remove some water, and then filtered. Next, the procedure for synthesis of hydroxyethyl ester. Palm oil was heated up to 150 degrees Celsius and poured some ethylene glycol with a molar ratio oil to ethylene glycol is 1 to 10 and also a base catalyst potassium carbonate about 8% mole of palm oil. The reaction time was set for 5 hours and the mixture was neutralized with 10% of hydrochloric acid solution and then extract with ethyl acetate. The organic layer was dried with sodium sulfate and then filtered using filter paper and following by evaporated using a rotary evaporator. This is the result and discussion. The fatty acid methyl ester as a synthesis product was analyzed by BIS-MAS Chromatogram profile from BIS-MAS analysis was shown in figure 1. In figure 1, we can see that there are 5 peaks which consist in chromatogram, and the chemical compound of each peak can be determined by analyzing of its mass spectrum. The result is presented in table 1. This is the fatty acid composition of palm oil. The main composition of palm oil is oleic acid, palmitic acid, and linoleic acid. Next, this is the result and discussion for hydroxyethyl ester. The conversion of palm oil into the is 72.9%. The TLC analysis was needed to monitoring this product. This picture was show the result of monitoring product synthesis by TLC analysis. The notes which marked with green filter was predicted as a hydroxyethyl ester product, and the notes which marked with a brown square was predicted as a triglycerides. According to this result, hydroxyethyl ester product was successfully formed because minimum notes of triglycerides in products and also form new nodes in product. The chromatogram have been given from BIS-MAS analysis shown in figure 3. This characterization was based on the peak which have been given in the chromatogram. The mass spectrum in each peak was analyzed to determine the chemical structure of this product. The result is presented in table 2. We know from this analysis the peak which have high relative composition is peak number 4 and number 5 as hexadecanoic acid 2-hydroxyethyl ester and octadecanoic acid 2-hydroxyethyl ester. The peak number 6 and number 7 is a byproduct of this synthesis as ethylene glycol diester. And this result is corresponding with the main fatty acid of palm oil consists of palmitic acid and oleic acid, which have higher percent composition than others. Next, this is the conclusion of this research. The hydroxyethyl ester compound was successfully synthesized through trans-esterification reaction between palm oil and ethylene glycol using potassium carbonate as a base catalyst. The conversion of triglycerides into the products is 72.9%, and the main composition of this product is hexadecanoic acid 2-hydroxyethyl ester and octadecanoic acid 2-hydroxyethyl ester with a byproduct as ethylene glycol diester. The authors would like to thank to Kementerian Energi dan Sumber Daya Mineral for financial support to this research, and also thank to PM Akamigas for the facilities for analysis. Thank you for your attention. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.